It depends. So that ideally the way you want to start is by scaling, right? So start with a couple users, add more and more users, watch the resource utilization, things like CPU and RAM. And when you start noticing those things maxing out, you want to migrate that to a bigger server. Now, if you're in a modern cloud environment, migrating to a bigger server is as simple as going in and clicking on settings and going, oh, I need more RAM, or I need more CPU utilization, or I just need a bigger instance, or whatever it may be, more storage space. However, there are a lot of legacy deployments out there where the server is sitting under the IT guy's desk, and if he spills his coffee, the whole server goes down. I wish I were joking.
No, I know you're not.
So it ideally you get to scale it. There are two ways of scaling servers. One is called horizontally and one is called vertically. So you can either get servers that are bigger and bigger, or you can add multiple clusters of servers and spread the load out across all of them. It is much easier to just throw resources at it, throw more RAM, throw more CPUs, throw all of that kind of stuff. But at a certain point, your code needs to be set up to run across multiple servers. So you have to go and refactor that. And that is horizontal scaling is when you add more resources. Vertical scaling is when you adapt your code to run on multiple servers. And so what you want to do is watch your resource utilization, and you can get a baseline of that by running it locally and seeing what resources it's running locally. There are also automated test platforms that can simulate, hey, what if 10 users hit this at the same time? What if 25 users hit this at the same time? What if 500,000 users hit this at the same time, right? And then you start watching your resource utilization and see where it breaks, because oftentimes it's not just your web server that's going to cause problems. Your database server may not be able to handle that load, or there might be issues with your authorization and your login and not being able to handle all of those users at once and track their security sessions. So there are a lot of different points that it breaks, but ideally when you're rolling out software, you want to roll that out and test that before you get all of your end users in there.
Because I've even, with my, I've walked into doctor's offices and they're, and they've even said to me, at a certain point in the day, all of a sudden everything just starts dragging and they have issues and they can't do enough. And I've always said, it sounds like maybe your server isn't handling everybody that's coming on. Mm-hmm. And they're, they'll say, when I get in first thing in the morning, I don't have any issues. And I can whip through, and then all of a sudden at such and such a time, everything's slowed down, it takes forever, or we have issues and this and that. And I might want to tell them that they may need to look into a bigger server. They're like, they look at me and I'm like,
so it's there are more modern web applications are REST based. So instead of a desktop class application, which tends to sign in, use the resources, and then use the resources whether or not you're loading a page or not, whether or not a lot of those old EMR based systems are using resources just because the computer is on and has that program open. So more REST-based things, it is a great way to scale, because it's just, hey, I need this patient's record. It gets the record, it uses the server resources, and then that's it, right? Yeah. That is not the case for legacy software. And so that's when you run into issues of server capacity and stuff like that. Don't get me wrong, you can run into server capacity issues with modern web apps as well. But when you're talking about web apps, you're talking about capacity issues at tens of thousands of users, not 100 users in the office that are slowing it down. Any other questions? Did I answer that?
No, you answered my question.
Okay, cool. All right, how are we doing?
Good.
I see we lost half the class from yesterday. Threw too much at you guys.
The cure's here somewhere.
So threw a lot at you yesterday. Cloud9 hated me, but we got a web server up and running. We built a front end from scratch with a little help from Bootstrap and Jquery. We got our front end and back end talking to each other. We made a put call and a get call. And we kind of built something where it's like, yeah, I could see building something like this in the future, right? So all of that was only maybe 100 lines of code total. So what I did, there is a glitch link higher up in the Slack channel that we're going to try and use instead. I heard through the grapevine that you guys were using glitch earlier on with maybe Zoe. So we're gonna try and use that again. But before we dive into the actual code, one thing that I always struggled with getting started was like, there's so many moving pieces here, right? And we did the planning and that's good and we got it all together. But it's important to take a step back and be like, okay, what is all of this, right? Like we connected it all together, it's all wired up, it's all working, but like that doesn't mean that we have to move on to the next thing. We can take a step back and go, okay, where does this go? What is this doing? What's this basic flow? So I posted in the Google Classroom, it's called slice.png, and it is my crazy marked up screenshot, right? So this is just the code that we were looking at. But I thought we would kind of go through it and start at the top, start at our HTML, and kind of just talk through everything that we did yesterday and what the flow is when we do this, where does this go, all that kind of stuff. That sound good?
Yeah, that'd be great.
If you want to follow the arrows along on this, you totally can. If you'd rather do it in glitch, which is where I'm going to do it so we can see the code a little clearer, that's also completely fine, whatever works. And I think if you download this picture, it will be more higher resolution, so you can read the code a little better. But we're going to start at our index.html. So it's kind of crazy looking at our front end, and without counting the interactivity of it, right, and not counting the JavaScript, we're kind of looking at these like 20 lines, maybe even less, that make up our whole front end, right? And maybe we're cheating a little bit because there's code down at the bottom, the card, the name, the timestamp, all that stuff. But for the most part, our whole front end is only 20 lines of code. So we start out by going, okay, let's make a container to hold all of this in. Let's make our message list, and then let's make our form, right? And the only really important part of all of this is that we put IDs on that. We put an ID on our message list. We put ID on our first name field, and we put ID on message and send button. Okay, so that's great. We have our front end set up. Now what do we do with it? So we drop down, we pull in Jquery, we pull in Moment. We'll use those later. Now we say send button.click. Okay, so where does this send button go? Well, if we scroll up, we see that it's a pound, so it's an ID. So send button must go up to our button up here. So now we've just wired that together, right? We've wired our front end into our interactivity of our JavaScript. Okay, that's all on the client, right? That's happening in the browser. Okay, so we drop down here, we get the name and the message, and those are HTML DOM elements, right? Those are the input tags. So we want the value of them. We don't want the actual DOM tag. So we use Jquery to call .val, and that links us back up to our text area and our input, pulls the value out of them, and stores them in name and message for us in our JavaScript. Okay, great. Now what do we want to do? We have our values. We want to get this out of client side. We want to get this up onto the server. So we do our fetch, we point it at our server, which is that chatroom app.glitch, and then we do a /send. So let's jump over to our server.js, and we see we have our app.put send. Okay, so now those two are wired together. So I should have an arrow drawn over there. So let's go back to our HTML. What are we sending? What are we fetching? Well, we have our body and we have our name and our message. And we had already pulled in our name and our message from line 44 and 45. So we're going to take that and we're going to send that up. So now that is in rec.body, and we know it's in the body because it says body right on the front end. So we're going to go back to our server, and on our server, we're going to messages.push with rec.body name and message. So now we bridge the gap, right? We went from front end to back end. We have our data. It's there. Now, what's this messages? Messages is going all the way up to line 24, which is just our array. Okay, so we're going to save that on the server. Now, why isn't messages in the send? Well, if it were in the send, it would disappear after the endpoint ran, right? This is a function. So once that function is done running, messages would disappear. So we want to define it out here. So when we put our message data into it, the server is going to keep it in memory. Okay, so we push our messages in, we console log it out, and we send back status okay, because we always have to send something back. So let's go back now to our HTML. Our HTML is going to get the response. That response is going to be whatever is in our res send, right? Our res send is going to have our message in it. We're going to parse out that JSON, and then we're just going to console log it on the front end. Okay, that takes care of all of the sending. Now we have to do the receiving, right? So what do? We do another fetch for our receive. We just are running this every second. So again, what do we have to do? We have to go back to our server code. We look at our server code. Our server code is doing a receive, right? Had we defined messages up in this send, we wouldn't have had access to the messages array. So that's another reason why we put it up here in line 24, so it's outside of our roots. So all we're—
Sorry, could you just say that again?
Mm-hmm. No problem. So our receive needs to be able to have access to the messages. So if we put what we have right now on line 24 just inside line 34, we wouldn't have access to it in our receive endpoint. We would only be able to get it in our send endpoint. So that's why we define it outside. Now when our receive request comes in, notice we don't do anything with rec in line 50 to 53 because we don't care what the client's sending in. All we care is that they want to receive. So we go to the receive endpoint, we grab our messages, we send it back to them. That gets sent back over JSON. Great. We go back to our index.html, and that goes into response. Our res.send has our messages object. We parse out that JSON, and then we have our JSON in my.json, and we do something similar. We do this content to update variable, and we put that outside the loop because we're going to loop over all the messages to build out our HTML. We put that out there. Now we have our my.json, which is the object and server. And in that object, we have our messages in a key, right? So we have our messages here. This messages is going to match these messages. Okay, so we go back to our index.html. Now we're looping over it, right? So we have message. We have an individual one. And what we're going to do is just add this HTML to our content to update. Our content to update is going to look in, get the message name, going to format the timestamp for us. It's going to add in the message, and it's going to concatenate it all to content to update. And it's going to run however many messages there are. It's going to get that giant HTML string. and then it's going to come outside of the loop, and it's going to go, all right, we're done looping over all of it. So content to update is now going to be a long list of HTML DOM elements with all of our message content and names and timestamps and all of that in it. And then we're going to use Jquery, and we're going to say, hey, go get message list. So we're going to go back up to the top. We are going to get our message list on line 17. And then Jquery is going to go, okay, what do you want to do with that message list? And we're going to say HTML, set the HTML to this content to update. And that's it. So sometimes it's helpful because we have so many different files going on that I literally print out the code, and exactly what I uploaded is what I will do. I'll go, wait, there's so many things going on here. There are functions calling other files that are calling the API. The API is returning data. Where is all of this going, right? How does this all wire up? And I find that it's helpful sometimes to just print out the code and draw arrows on it. I know it looks crazy, and you look at it and you go, I don't know what he's thinking here, but it's at least helpful to me to kind of wire everything up. So just because it works doesn't mean that we have to like, okay, move on. It's important to understand it all together. Any questions? Okay, so we have 3 objectives today. We need to get our messages saving to a file. We need to cover using a templating language called EJS, and we're going to cover sockets a little bit. And sockets are going to make it so we don't have to refresh the page every second to see if there are new messages. And Alice is going to cover that for us. But before we do that, there is one piece of functionality that's really bothering me. That was the extra credit last night. By the way, to run this, you go show and then hit in new window, and it will open up your index.html. So I'm going to type in my name. I'm going to type in a message. I'm going to hit send, and this didn't clear. That's really bothering me. Did anyone figure out last night how to get that to clear? Yes. First of all, where do we want it to clear?
So I put it in the fetch request.
Yep, that's fine. What fetch request?
The send.
Okay, and why do we want to put it there?
Because after you send, you want it to clear.
Yep. So we're going to put that maybe right in there.
Yep, inside the myJSON function.
Yep.
And I put $, parentheses,
Mm-hmm.
and a string that's ID of message,
Mm-hmm.
dot val with an empty string.
And then
So
we'll.
it'll make the value nothing after.
Yep.
And then the same thing for name.
So basically what we're doing here is we are telling, hey, Jquery, right? The $sign means Jquery. Go get the message, the input DOM with the ID of message, and set the value to an empty string. So notice down up here, we use val, but we don't put anything in the parameters. And so Jquery goes, oh, well, if you don't tell me what you want it set to, it must mean that you want to get that value back out. But because we put the empty string in here, now Jquery goes, oh, you don't want to get the value, you want to set the value. What do you want to set the value to? Just an empty string. So if we go back here, we do max and hello world, and we hit send, we notice that it clears out for us. Cool. All right. All kinds of different things that we could do on this app. We could we could make sure that these form fields aren't empty before we send it. We could do server-side validation for that. So basically, there are two ways of handling empty fields, right? You could either do it on the front end and say, hey, if these fields are empty, don't do the fetch request. Or we could do that on the back end. Generally, it's preferred to do it in both places. And the reason why you want to do that is you do it on the front end because you want to show an error. You want to say to the user, hey, you need to fill out these form fields before you can send a message. The reason why you want to do it on the back end is if someone gets crafty and disables JavaScript on the front end and still makes that web request to you, your server, you want to check that on the server and make sure, hey, make sure both fields are here before we go ahead and save that in. But because this is a basic chat app, we don't need to dive too far into it. So I want to create a new button that I can hit the save button right here, and it's going to create a file on the server, just a plain text file that saves out all of our messages for us. Go. Where do we start? Create the button. So I'm just going to copy our send button. I'm going to put it outside the form because it's not really related to sending a message. Our ID is going to be save button, and we'll call it save. And we'll take a look over here. No glitch. I'm going to comment out our receive. What I believe is happening here is that because all of us have this loaded, it's doing so many API calls every second to the receive endpoint to get all the messages that glitch is like, we've had enough of you, you can't load your project. So we are going to just assume that our save button worked until our requests get back here. So what do we do now? We have our button in the interface. We probably need to make it do something on the server, maybe, right? Because all the messages are, well, we could do this on the front end, but the boss man says that he wants the file on the server, right? He wants to be able to like export all the messages that have been sent. So how would we go about doing that? So we have our button on the front end, and we want to save a file on the back end. So how do we get the front end to do something on the back end?
Save.
Sure. So So let's set up our endpoint. So we're going to come in here and we're going to do an app.get, and we're going to do a save, and we're going to do our recres. And something that I like to do is whenever I make endpoints, I always forget to send something back. So I like to do my res.send right away. And I'll just say message, okay. And what that prevents us from doing is making an API call on the front end and having it just constantly loading and loading. And even though it saved the file, it's really easy to forget to send something back from the server and be like, okay, the server is done. Okay, so we are going to do something new. We are going to do FS. And FS stands for file system. And my iPad's going to hate me. Well, are you gonna let me open Google Drive? Thank you. So what we are going to do is, of course I didn't write notes for that. Okay, so what we're going to do is we are going to pull in FS. So normally we would npm install fs because we're using the new require, but fs is one of those special ones that is just built into Node, so we shouldn't have to install it. And what we're going to do is come down here, and we are going to do a test before we get our messages in there, right? So we are going to do fs.write file, and we are going to go to the fs documentation. And we're going to do a search for write file. And what this does is it shows us the parameters that it wants to take, right? So it needs a file, and it needs the data that it's going to save, right? So it basically needs where it's going to save it. And in this example, it might be a little bit more clear. Save message.txt, okay, and what do you want to put in it? Well, we want to put in some text. So what we're going to do is go back here, and we're just going to say, hey, create a new file called message.txt. And what do we want to put in it? Hello world. Okay. Oh, and we're going to probably put that in our endpoint instead of putting it in our listen. Okay.
So we get 4,000 requests an hour with 4,000 bursts. So we must have gone through that already.
An hour?
An hour.
Well, it's 6:01.
I don't know when it. So we could remix this project.
Sure.
Project. Hooray.
Okay. New link. We're gonna just share the code copy and paste that in there. Okay. And what we're going to do is make sure to be careful. We're actually going to take out our set interval here just to make sure that this code isn't running every second, so we don't run into limits with glitch. Okay. So we have our server.js. Oh, we need to update our front end to use our new URLs as well. So we are going to change that here. And we're going to change that here. Okay. So now what? That's interesting. So yes, we should test it. How do we test it? Go here, and we'll do a test, and we'll send. And we'll go to our server logs, and we'll see that we have some messages in here. All right. And we're going to hit, I'm going to just clear these out for now. All right. So when we hit the save button, we should get our message.txt, right? Okay. I hit save. Go over here. What did we forget? Yep. We have to tell our front end, hey, go call that endpoint. Go say /save. So how do we do that? We have our button up here. It has an ID of save button. Connect to a fetch. And how do we tell it? Not only do we want it to fetch, we want it to fetch at a specific time. So when do we want it to fetch? On click. So we are going to use Jquery to get our save button. And on our click, we are going to have it do some event. And we will event.prevent default to prevent the browser from refreshing itself. And now we want to do our fetch. And we're going to copy some of this code. We already had it working once. No reason we can't use it again. And instead of receive, we want to send. And then we can just console.log my JSON to see what our response is. So we will save.
You have to change the get.
We need to change the URL. We do not need to change the method because we are using a get on the server side as well. We're going to close out our onClick function. We're going to fix indentation. And we are going to go back here. We are going to hit save. And we're going to come back here. And we have calling an asynchronous function without a callback is depreciated. Okay, but that's just the warning. We're going to change this to synchronous. So have you guys covered asynchronous versus synchronous? Okay. So we're just going to make that a synchronous call instead. Because we don't really care, right? We want it to run and save before the server says, okay, we have it saved.
Where are you doing that?
What's that?
Where are you doing that?
Right here. Right file sync.
I mean, which file and what line?
Oh, server.js, line 57. Okay, so let's try that again. Let's do a test, and we'll send it. And we'll do a quick refresh on that. So our message is showing up, and now we hit save. And we still don't have anything over here. All right, so what my guess is happening here, it's interesting that we're not getting any errors. So in order to test to see if our save endpoint is actually working, we're going to throw in a console.log, right? We're going to try and debug here. And we'll just say hit. So we're going to come back here. We're going to do our, we can just hit the save button, and we're going to come back over here, and it says hit. So we know it's communicating, right? So there must be something wrong with our fs write file sync. Any guesses on what?
Can't figure out how to get little logs page because it's gray.
It's under tools and then logs.
It doesn't let us open one. Yeah, we'd have to.
Oh,
That's okay.
sorry.
Okay, no, it's all right.
I can give you guys that share link. I guess you need edit access.
I mean, it's all right. I was just.
Okay.
It's just easier to see, but it's okay.
So what I think is happening here is we're passing in a relative file path, and Node doesn't want to write to a relative file path. So instead, we have to go back and remember how we used our dir name up here. That's what we need to pass in here. So we're going to do __ dir name /message/txt. And so we'll go back here, we'll hit our save button, and we still don't have anything. Glitch limitations with FS?
Could we try writing to the data directly? Not data. Oh, no, it shouldn't be fine.
Maybe does it want to go into the assets folder? It's weird that it's not even throwing an error. Just do a quick look in our console in the browser. Oh, and we have some errors in the browser. Okay, so it says unexpected token So let's go, let's hit save. Let's look in our network tab and at 500, right? So 500 means that there's an issue with the server. And the response was no such file. Okay, so that is something to go off of. Cannot get app assets message.txt. Did I spell assets right? I did.
We have a file called message.txt.
No, but we shouldn't need it. It should create one for us.
Oh. Did it?
Wondering if
We already
I,
had index.html. When we used that for your name.
yeah, let's give it a try, right?
Yeah.
What's the worst that can happen? Message.txt, and we should get hello world in that if we hit the save button and we come back and we still don't have.
Go to tools real quick,
Mm-hmm.
then full page console,
Mm-hmm.
then type refresh.
Oh, okay. So we just
It's I think it's a limitation with the editor.
gotcha. Okay, so we just need to remember to refresh glitch. You won't have to do that locally. When you FS to your file system on your Mac, it will automatically update the files for you in VS Code.
And so in this, you don't know if we actually needed to create the file either.
We can delete it
See what happens.
and then refresh it and then see that we still don't have anything here, and then go back to our chat room app and hit save, and then come in here. We still don't have it, but if we refresh in our console again, I don't know, I have a restarting. We have our message.
Cool. Just good to know.
Yep. Okay, so what do we need to do now? We have our file created, but hello world isn't cutting it for me.
Populate the file
Yep. And where are we populating it from?
from the server.
The server, where on the server?
At, get dot save or get slash save.
So we're saving everything in our messages object.
Yeah.
So what we want to do, let's think about how we did this on the front end, right? On the front end, we did this crazy formatting because we needed it in HTML. But we looped over all the messages, formatted it in however we wanted, and then put that out into one giant string, right? So what we want to do is that same thing on our server side. So what we're going to do is in our save method, we're going to say for const message of messages. And what is messages? Messages is already defined for us up here. So for messages of messages, we are going to do a variable outside of that loop called toSave, and it's just going to be an empty string. And in our messages, let's do something like toSave plus equals. We'll do a template literal again, and we'll do message.name and maybe a space, and in parentheses, we will do our message.timestamp. But let's get fancy with that. I knew there was a reason we installed Moment yesterday. We will pass in Moment, and we will format that with an LT. And then let's maybe do a colon, and then do our message.content. And we're going to check and make sure this is actually message, not content. Okay? Is this going to work? Well, let's try it. We're going to save. We're going to refresh. and we're gonna go to our message.txt, and we still have hello world. Forgot one step. We created this lovely to save, but now we have to tell it to write it into the file. So we're gonna go back to our app. We're gonna send a message. We will do another message, and we'll do a final message, and we will refresh this. We'll see that our messages are in here. We will hit save. We'll go to our glitch console and refresh it, and we're gonna go to our message.txt.
Sweet.
And we got things in there. And I believe, I could be wrong about this, but I believe the new line indicator for txt files is \n. So we're going to throw that in there. And we are going to refresh this. Test two, and we'll hit save, and we will refresh, and then we will get our message.txt. That looks pretty good. Cool. Socket time.
Nice. Okay.
Do you want to just use my computer because it's set up for the Zoom live stream?
Easiest.
Cool.
Max, LT is a moment thing that means
Yeah.
time. That would be
I don't know
Just change
what
the
it stands
formatting
for.
of the time.
It changes the format. If you go to moment.js.com.
Yeah, I just wanted to make sure that was what.
Why is it,
Okay.
yeah, why does it say 10:15,
Because that's the time zone of the server, which would
4 hours
be GMT, which would make sense, or UTC time zone.
Okay.
I'm sorry.
Oh, sorry.
Is that because glitch is based in England?
A lot of it could be.
Okay.
A lot of servers default to GMT or UTC time zone because it's not plus or minus anything. So
Zero.
ETC is -4.
Okay, but you can change that, right? Jake, the moment code?
There's a library called Moment time zone that would allow you to convert from UTC
Okay.
to the user's time zone.
Okay.
Date and times is the bane of all developers' existence because you start like writing out your code and you go, oh yeah, one user in the East Coast did this at 4 o'clock and the other user did this at 3 hours earlier, but it was 2 minutes later. How is that?
Yeah.
Like, how does that? Oh, it's because they were, in LA. So you start handling those time zones and you need to start figuring out how you store them and how you convert them as well. So what happens if a user is using your app on the East Coast, closes their laptop, flies across the country, their laptop time automatically changes, but now all of a sudden their timestamps are wrong. So those are all things that come into consideration when you're developing an app with time zones is how do we support them? What do we convert? All of that kind of stuff. Oh yeah, that reaction is completely warranted because you think your app is working and everything's fine and your whole company tests it on the East Coast and you're like, great, I'm done, I'm good to go. And then you have another user who contacts you and they're like, all of these times are off by 4 hours, right? You're like, oh crap. But yeah, that's the joys of time zones.
I'm sure I would very much handle that. I would handle that very well. I wouldn't scream or cry.
The ideal answer is try not to handle it if you don't have to.
Yes.
So somebody else has probably already handled it for you. Okay. So WebSockets, it's like HTTP, but different. So WebSockets are actually a protocol built on top of HTTP. Like if you were to start up a new web app that uses WebSockets and you look at the traffic in the web inspector, it starts as HTTP and then gets upgraded to WebSockets if there is actually if the server can support WebSockets. In this case, ours will. So you could always go in later and look at that if you wanted to. One of the main benefits of WebSockets, unlike REST, we had to do the set interval to do polling to actually let us get the messages back. WebSocket supports what's called full duplexing, which means both the server and the web browser can talk to each other at the same time without having to wait for either one to respond. So we're going to do that now, so we don't have to do that set interval everything and break our glitch projects forever. So the first thing we're going to do, there is a package called socket.io. It's going to handle a lot of the tricky parts of,
Maybe socket.io without the dot.
Nope, it's there. I don't know why it disappeared all of a sudden, but we got it.
And how would we normally install that if we were on glitch?
Required.
npm install, and then yeah, we'll require it in a second.
Mm-hmm. So there's another quick thing we got to do. So to install socket.io, we just want to do const io equals require socket.io. Just like that. So socket.io is really, it needs a specific note. Remember how before we used Express, going way back to Monday, we used Node's HTTP library. We use create server. We have to build a server first. Thankfully, we can cut it down to only one line of code. So we can do HTTP equals const HTTP equals require HTTP. Then we can do, have to do this after Express because we do need Express. Or is that after app? It's after app. Do you mind if I get my laptop actually? Because I do have this right now and I cannot remember.
Totally got it. That's why I use the iPad.
Yep. 1 minute, folks.
Well, I have a question. And then I'll give you a moment.
Sure.
Well, what exactly is a server? Like, I remember at one of my jobs, there was a server or never going now.
So
I had this idea it looked like a satellite. I mean,
So-
like, I know what it does, but I don't know what it is.
So a server is just it's very similar to a PC tower, except that it is designed to be used by multiple people instead of a PC, which is personal computer, right? So servers have all the same components as a PC or as your Mac in front of you, right? It has RAM, it has CPU, it has a network card. It might not have a graphics card because it's, shared by everyone. But all at the end of the day, it probably is running a different operating system, and that operating system is designed to handle multiple users. It's designed to handle networking a little bit better. It's designed to handle things like file permissions a little bit better. But at the end of the day, you can clearly you're running a server on your Mac right now, right? So it is just the hardware is the same. It's just the way you're using that computer, and that just happens to be to serve different content or information or data or whatever.
Okay.
Okay. So have HTTP. We can do constant. We need it after Express. So basically, this line of code here is going to tell the node server, hey, make a node server, but use Express to handle all your requests. So we can do, let's see. Oh, I see what they did. They just did one line here. I'll just copy this guy. Remember, I'm on a Mac. Dot server app. And finally, we can do copy this guy down here because errors. So this syntax here, it's a little bit different than what we've been doing so far. Basically, require statement just turns whatever your module returns. So in this case, instead of returning an object, it returns a function. So you can think of this part here just as a function, and it just takes a parameter, HTTP. And finally, we get our IO variable, which is what we're going to be using to make our sockets. So now that we've got all that set up, first thing we're going to want to do, we're going to want to be able to tell when a user gets connected. So we can do io.on. What is it? Connection. And this is callback is going to give us a socket object. We can just do total.log user has connected.
So the reason why we want to do connections, right, is REST is very transactional, right? We want to get the messages, we got the messages, okay, we're gone. Sockets are more about the connection, right? Because we want to be able to have the server be able to tell all the other end users, hey, a new message came in. So that's why the connection is more important and why we didn't do that in Express. Express got the connection, it got the data, and sent it back and went, okay, I'm done with you. With the socket, we want to open up that connection and keep that connection open the whole time the user is on the site. And because we have that connection open, we can now send information back down to them with the new messages.
And that kind of has another benefit too. Like we hit that 4,000 connection limit really fast using REST. With this, we won't hit it for a long time.
Right.
Okay, so now that we have this, we can go back to index.html. We just want to do this on page load. Let's see. So there's some jQuery syntax we're going to do. This basically just means run this on page load. Oh, first we actually have to include the socket.io client script. Nice thing the socket.io library does, sets up the script for us right at right on the server itself, so you don't have to go out to like a CDN like we did for jQuery or Bootstrap to get. And that is given in the documentation, but I have it written down here. It's just /socket.io/socket.io.js.
And what is that?
So this is the client JavaScript file that Socket.io provides to anybody who wants to connect to it. It makes it so you don't have to go out and download the client JS yourself from like a CDN. You can just get it right from the API you're connecting to.
So just like we pull in jQuery and just like we pulled in Moment, instead of pulling in Moment from the hosted, Moment project, instead of going and pulling socket.io in from socket.io, we're going to pull socket.io in from our own server, which is why that URL doesn't have anything else in front of it. It's just going to look at our own server instead of going out to the public internet and pulling the project in.
Mm-hmm. So now we can come back to our JavaScript. We can say const.io equals oops, sorry, got that backwards. Const socket equals IO. Then we can do.
And we have access to that IO object because we pulled in this script from above.
Mm-hmm. Yep. So we can just do socket.emit. Then, oh no, connection. Okay. So this part here, when we just call IO, that is what opens the connection to the socket. You don't have to do anything special to open the connection.
And you said that empty parentheses just means like whenever the page opens, it like starts that.
This one here on 118?
Yeah.
Yeah. So like over up here, we have these click events.
So you don't have to do, like, essentially that means like nothing has to happen. You just have to like be open.
Yes. Yep. Yep.
So how do we know our connection is open?
So we can open up the logs. We can open up next to the code. Refresh. Ideally, I would say users connected here, but that's not happening.
Can you console log something in that section?
Yeah. It's a good idea. In this case, because this is a that is the Node.js logs, we'll have to just look at the is it Command-Alt-I. Yep. Go to console. Oh. That's fun.
It says hi.
It does say hi. That's good. So we're getting that part working. So the problem here, this 404 error, that means it can't find the socket.io JavaScript, which means I did something wrong when I was doing socket.io. So I'm just going to look this over real quick.
Or you don't need to serve the file, or the res.send file.
Where's that send file? That's not how the documentation showed it up. Nothing ever works when you're trying to demo it.
Supposed to say app.
Yep. No. So we pass the Express app to the node. Nodes require HTTP module.
Oh.
Then that becomes HTTP, and then that's what goes to
I see.
socket.io.
Okay, sorry.
Oh, that's okay.
Can you pull that library in from a CDN just to keep the demo moving?
Yeah. Oops. Say 3% CA real quick. Socket.io. Client CD. Plausible scaling. Oops. On a Mac. Checking the. Well, because it's helped us before.
Well, we can move to the templating engine while you play with that,
I'm
and
gonna
then
figure
we'll
this
circle
out.
back.
Sorry about that. No.
Oh, these are actually different errors. 404ing on the serving.
Yeah,
So I think something's wrong on the server side,
that would make sense.
which is why it wasn't serving that file to get started. Does it need the port number in? No, because you're passing an express, so that shouldn't be causing problems.
Oh, no, you're right. So.
Server listen on 80.
Do we have to use 80?
Not that part. At the bottom, when we tell Express Solution.
Yep.
You gotta change that to HTTP.
So we'll just comment that out and do app.http listen.
Yes.
And then 80, I'm guessing.
Yep, that should be fine.
And then just clear, and let's refresh this here. And let's clear our console and refresh.
No, it doesn't like order 80.
It does not want to bind to 80.
Let's change back to 81. Sorry.
User is connected.
Hey, look at that.
Okay, you can take that over.
Sorry. Sorry.
All live debugging.
All live debugging.
So the issue we had, right, was that we had told Express, hey, go fire up your server, go Express, go do 8081. We created our socket IO server, but then we didn't actually tell socket IO to turn on. So that's what we just swapped out there, and now all of a sudden socket IO is like, yeah, great, I'm on, I'm running. And then all of your front ends connected, and when a user is connected, a user is connected, a user is connected. So now we have that open bridgeway. Right, now we have the connection. So what are we gonna do?
Okay, so there's two different ways we could go about this. Probably the most representative of the way you'd see of like a normal chat app using this. We can actually send messages back and forth just using socket IO without even needing REST at this point. So we're going to modify this a bit. So the first thing we're going to do, right after we do this connection here, we got to do this on the server actually. We want, when somebody first connects, they probably want to see the chat history, right? So we'll send them back a list of messages. So we can go, where is that? Right here. We can say socket.emit. And emit is just the function that Socket.io uses to send a message. So we want to give the message a name. In this case, we'll call send message, or yeah, send messages work. And we'll send it back our messages object. Now we go back to our HTML. We want to say socket.on send message. Nope, space, no hyphen. Make sure that that's actually right before we go down this road. Yep. Nope, looking at the wrong one. Yep. Then we do the callback message. I guess in this case, we want to say messages. Okay, so we already have the code built, right? That lets us show the messages. So we can just copy that code all the way down from this 4 here. Oh, actually, you probably want to select 2. Command C. Command V. Okay. I'm going to change this a bit. Since we're just setting it the base messages object, we can just change this to MSGS. We're going to send it a few messages. Test name. Hi. Test name 2. Oops. Whoa. And we're going to refresh the page. There we go. So it's right up when you log in. Actually, I don't think that other one is commented out. Just comment this out just to confirm that that's actually what's loading the message. Everything except the save button. So there we go. But when we send a message, another one, we still don't get it back. So we also need to modify our send. Oh, we know why? Because the send button, we commented that out. That also doesn't work. Okay. We can modify our send button click. So we can do Jquery, send button. Click. Event. So we want to do event.prevent default again to keep the form from submitting like it did when I forgot to do it the first time. Instead of needing the fetch though, we can just do, actually I'm going to move this down here so we can get inside the, oops. Needed to be in the scope of the socket variable. say one more tab, socket.emit. We're going to call this new message. And create a new message object. Oh dear, what is going on now? All right, so the message is going to be, let's see, what did he call that? I can just copy these here. All right, so we get our values for name and message. And if I just put them in the right spot. Oh. Okay, so refresh this. Oh yeah, thank you. JSON, no semicolons there. So we can try test 3. Oh, go away? Okay. Yeah. So not sending, but at least we stopped it from reloading the form. So if that just means we got back to our server now, and we can tell our server to listen for that new message. So we can go up here to our IO on connection. We can say socket.on new message. Message. I'm going to close this. So we have the code we need to put our stuff in the messages. So we can just copy this. Okay, so we just want to do message.name.
So we're changing it from rec.body, right? Because the data isn't coming in from the request anymore. The data is now coming in from the socket information. So that's what we're changing. Is we still want to save it in that same messages object. That's still going to sit on our node server in memory, but we're just changing the source of the information. So instead of it coming in our REST body, it's now coming in over the socket information.
Mm-hmm. So good, that should save our messages. We can do console.log messages like we did before. And we can start the app again. And we can start the app again. S3, message. So it's there. And the last thing we have to do now is make it show up after we actually send the message. And that's really simple. So remember before how we did socket.emit send message, and that just caused it to load in? We can just do the same thing in here. Socket.emit send message, messages. Refresh this one more time. Name, message, send. And there we go. This is 34, 56,
Now, the magic of this is if you guys look on your screen without having to refresh it, you should be seeing those messages come in immediately.
Do it again.
Okay. Message.
Sorry.
5. Oops. Show up.
Show up,
Did you refresh your page?
refresh it once.
I mean, I refreshed it so that 56 and 34 show. But 5 has.
5 has not showed up yet.
What the F, man?
Here, you tried send a message.
Me?
Yep.
And we should be able to see it immediately up here.
I keep wanting to press that. Oh, I'm gonna see that.
Are you,
Sure, if I'm wrong.
as
So I just refreshed it.
Good night.
Okay. It's not showing up either. I thought mine. I didn't see yours. Yep, after I refreshed it,
yeah, so the whole point of the sockets
so you don't have.
is that you shouldn't have to hit refresh.
Mhm.
Oh, sorry. It's not socket.emit. It's io.emit. Oops.
Broke it.
I broke it.
I was gonna ask you, because I keep, whenever I,
There we go.
Yeah, it's working. so when I do this, how do you make it so like you press return? I can do that.
We'll get back to that.
Okay, because I keep doing it out of habit, and I was like, no, that's not what I want. I don't like clicking.
Cool. So questions about this? About sockets? If you refresh the page just once, the socket should.
Are you doing it on your own?
Yeah, so we all have to be connected to the same server for the sockets to work.
Yeah, could we just go through that by steps? Like just like plain language, just like without the coding, because
He
like
did it on there.
Yeah,
Yeah.
yeah. Let me switch off and I will go through that.
I'm actually just gonna talk through the code and we're gonna do, oh, sorry,
Okay,
sorry.
like the flow charts.
Yeah, what we did at the beginning of class, we're gonna talk through that. Okay.
Yes, thank you.
Can someone just check the live stream because I knocked out the HDMI, so I want to make sure that's still showing. It should be. Zoom's pretty good, but
Are we gonna take a break at 7?
sure.
Okay, I'll wait 2 seconds.
All right. So let's just talk through this code and then we can take a break.
Okay.
All right. So the best way to think about this is how we did it with REST, right? So with REST, we had 2 endpoints. We had our send and we had our receive. The issue with our receive is that when the send happened, we couldn't tell the receive to go fire on everyone else's computer and go get the new messages. So that's the whole reason why we want to do socket IO, right? And that's a really important thing to focus on. It's like you'll go to the JavaScript meetup or the Open Hack or whatever, and people are like, I'm learning this new technology. It's awesome. It does X, Y, and Z. And you're like, yeah, man, I want to go learn that new technology. And you get halfway into it and you go to the next Open Hack, and then people are like, oh, I'm learning this new technology. And you're like, whoa, I was just learning that one. Hold on. So it's important to identify, like, why should we use this package? What features does it have? Is this better than what I am doing? Because if you just constantly jump onto the next new thing, you'll never be able to complete any one project. So it's important to identify, like, why are we using this? And the reason why we're using sockets is, so the way we had our REST app built was that it was saying, hey, every second, go see if there are new messages. And we clearly hit a limit, right? Which is why we had to go into this new link, was because all of you were asking the server every second, are there new messages? The server was like, whoa, way too many messages, and hit its limit. So what we moved it to instead is sockets. And the benefit of sockets is it's two-way communication. So when a new message gets sent, the server gets that new message in from the user and then sends that message back out to everyone else and goes, hey, everyone who's listening, who you just have one connection open with, per person, hey, I have new information for you. Here is that new information. Here's how you handle it. Now we could get into optimizing this. We could make it, instead of sending the entire message history, we could make it send only the new message, but we're not going to worry about optimization for now. So let's talk about what we did here. So we went on the server, and we, instead of setting up Express and using app, instead we followed similar steps here on line 14 and 16. And Wanda, only because I know you're listening, I will go back through and comment this tonight. We're going to go in 14 and 16, and we're going to set up the new server, right? And we have this new IO object. So instead of doing app.get, we're going to use IO instead. All right, we still have our code here because we're doing we're still using FS, we're still using Moment. But what we have here is our IO on connection, right? And so here's the first difference between Express and REST and Sockets. Sockets, you need to open the connection. And once the connection is open, you can put whatever data you want in it and send it and receive it. But first, we need to open that connection. So we say, hey, IO on connection. Now we have our socket object. And what we're going to do here is we're going to, now that we have our socket, we can use that down the road. So when a user connects, we're going to console log out user connected, so we see users coming into the server. And what we're going to do is, as soon as they connect, we're going to emit. We're going to res.send, right? We're going to send them all the messages, because as soon as you open the app, you want to see all the message history. Great. Let's pause there for a second. We'll get back to the new message. So what do we do? Where does that emit go? So let's switch back over to our front end. Our front end, up at the very top here, we have our socket.io. So just like we pulled in Jquery, just like we pulled in Moment, we want to pull in our socket.io so we have access to all the goodiness of sockets. Because goodiness is totally a word. Definitely need a break at 7. Okay. So what are we going to do? We're going to come in here. This is just some Jquery syntax to make sure that the page is ready before we do any socket information. We're going to take out the console log. We don't need it anymore. Okay, so just like we set up our socket server on Express on the back end, we also need to set up our socket on the front end so we can have all of that stuff. So we got our socket. Yeah. Yep. I'm 119 on index.html. So I'm on. I pulled in my IO from that file up above, and now we call that socket. So what do? We say, okay, socket on send message, right? Which you will notice, we go back to our server, has our emit send message. So now those two are connected. So it's going to say, okay, well, send message, we're going to send that, we're going to emit that on the server side. So on the client side, when you get that emitted to you, what do we want to do? Well, that messages is going to get passed in. Okay, we're going to go in just like we did on our REST-based API.
So you're going to make a new card.
We're going to make the new card. Yep, and we're going to make the cards for all the messages that are passed in. Correct. And that's going to have all of our HTML in it. We're going to update that, and that's it. So that's all we're going to do on send message. And so that's why when you do your first connection to the server, the front end is going to load. It's going to load index.html. It's going to set up our IO connection. That IO connection is going to trigger this IO on connection. The IO on connection, the server is going to trigger send message with all the messages in it. We're going to go back to the front end. The front end is going to go, oh, on send message. That's the server just sent that out. What do you want to do? Oh, I want to take all the data from those messages, build out my HTML, and set it in the content. Okay, that's only for receiving. That's only for opening the page, getting the connection set up. It gets all the messages in, and it's like, great, I'm done. So that's why when you load the page for the first time, that flow works. Okay, now what else do we need to do? Well, we just took care of sending, or I'm sorry, we just took care of getting all the messages, receiving all the messages, showing the messages. Now we have to handle sending one, right? So we still do our send button click, which is just our regular jQuery, just like we did in the rest. We still prevent the default because we don't want HTML to submit the form. Okay, and now what we're going to do is instead of doing a socket.on, instead of receiving, excuse me, instead of receiving the emitted event, we're going to send an event. We're going to emit it from the client side. So we're going to emit a new message. And we're going to call it new message so it knows what that event is happening or is called. And we're going to send some data with it. The data we're going to send with it is the name and the message. Okay, so now the server is like, oh, one of my clients, one of the front ends is emitting something. Okay, so let's go to the server. And what we do is we tell the server, hey, handle socket on new message, right? This is a two-way street. The server can emit or the client can emit. And the client can on something or the server can on something, right? It goes back and forth. So what we do on the servers, we say on new message, when a new message comes in, grab that data, put it in the message element. Okay, go ahead and push that data into our messages object that's on the server, log it out so we know that it's working, and that's it. But we have one more thing. When you send up a message from the client to the server wants to save it, but we want to tell everyone else that's connected, hey, there's a new message. So what do? We emit out that send message. So this emit send message is not only going to go to everyone else who already has the page open and goes, oh, on send message, go ahead and format out my HTML, send it back to me. It is also going to trigger on the one who sent the message. So now when I hit that send button, my message data goes up to the server. It gets saved in the server. The server emits out the send message to everyone, including me. And now my computer is going to go, oh, I need to go build the new HTML. What HTML do I build? Oh, you sent the messages to me in this send message event. Let me iterate through them. Let me throw it in the HTML, and I'm done.
When it's IO, it's the server doing something. When it's the second, the user.
Not necessarily. It just depends what we called it. So on the server, the IO on connection is just to. You have a good way to describe socket versus IO?
So in this case, it seems like socket is what you do with incoming data, and then IO is what you use outgoing.
Yeah.
Right. So
Yeah.
like when you do the IO.connection, connection, that's like saying the server is saying, hey, I'm set for connections, connect with me. Then when something connects, you get that socket object, which means that the server is saying, hey, I have the socket object, so I can do stuff with the data. So then when you do like socket.on new message, that's the server saying, hey, if you send me a new message with the messages attached, I can add those messages for you. And then when it does emit, it's going out and telling everybody, hey, everybody, this new message, here it is. So IO is like telling the client something, socket is like getting the messages from the client, but both of them happen on the server.
So you defined IO
Where?
as a con,
Yep, right here.
but socket not. So the socket just is
The
object
socket-
that comes with the socket.io.
Correct.
package.
Correct.
I just needed to be clear about that. Like,
So this is a callback. This socket right here is
Yeah.
a callback. So basically when we create this io.on and we say connection, the socket IO library is creating the socket
it's
for
socket
us.
object.
And now we get to do .on that socket because it's part of the package that it's getting passed in with the callback.
Yes, okay, that makes sense.
If we were doing this on Visual Studio Code, we wouldn't have to download or
You would have to install socket IO
every time.
for the project, right? Because you would do npm install -- save instead of installing it globally. And it's socket IO. In this case, it would be better to save it at the project level because you may do another project down the road that uses a newer version of socket IO. So that's why you want to scope it at the project level.
Okay.
Break time? Break time. 7:05.
That was really fast, I just sent that. Also, why is it not clearing now?
Because the server, what do you mean, why isn't it clearing?
So name and message don't clear after you send now.
Oh, sure, we can fix that quickly. So that's just an index.html. When we do our click, we don't have our val code in here to clear it.
Oh,
So we just would put that in here. And now it should clear.
So this whole editor, this is all using WebSockets on the back end.
So that's why when I'm typing, you guys can see me typing. Those are all WebSockets.
that's cool. So,
This is just like one thing you can do with WebSockets. Also Slack, if you ever use that.
Or messenger.
Yep.
Messenger is basically the same thing.
Yep. Okay, break time. I'm now going to picked up on the live stream. So they can, AWS, you can say, hey, I want a static IP address. And you can do that with Time Warner as well. So you could say, they would charge you like $150 a month, and then you would get an IP address that's assigned to your modem. And that doesn't change. And if you pull out the plug and plug it back in, you're going to get that IP address again. And then what you do is DNS, which we're going to cover in a couple of weeks, you would get your domain name, mywebsite.com, and point it at that IP address that Time Warner gave you.
And that would act as your server.
That would
Well, it would.
that would point
You
your
would build a
domain
server.
to your server, and then you would have to have your server running, just like we're running Node with NodeMon and whatever else. You would run it like that.
I'm just like, thinking out, I guess, supposedly thinking out loud, whatever got to the point where I was working from home.
I work from home, do not have a server. Ross works from home, he does not have a server. We just host everything on Google. And you would be hard pressed to find a startup that has their own physical hardware these days. There are just so many advantages to hosting in the cloud, and cloud hardware continues to get cheaper. And Ross spills coffee on your server, and now you're offline, and you have to drive to Best Buy and get a new server. Data centers, the IT guys aren't spilling coffee on the servers, and if they are, they're fail safes and fallbacks, two different words, to automatically roll over to another server. Any other questions?
Yeah, I'm still curious about what advancements Apple announced at their web developer conference that were important.
Sure. So I would say the biggest one to keep an eye on is Catalina is their new operating system, which is nothing new. They do new OSs every year. But they have a new project called Catalyst. And the big thing with Catalyst is right now, when you create an iPad app, it runs on the iPhone. That's it. You write your code one place, it runs on the iPad, it runs on the iPhone. But if you want it to run on the Mac, too bad. You have to rewrite your whole app. And so the big news that they announced was that they have this new framework called Catalyst, and you can import that and just with a few little tweaks, have the app that you already built on your iPhone to run natively on your Mac. They also announced a new UI framework. So think Bootstrap, but for native apps, that allows you to use components that are already built and kind of have a UI layout and build it all there without having to build it in, I'm blanking on what they call it in Xcode. Storyboards, without having to build it in storyboards, which is their current method of wiring up UI frameworks.
And then there was something about a new security measure where you sign in with your.
Oh yeah, there's so when you go to Glitch, right, and there's a sign in button, you can sign in with your email and then have to do the whole password thing, or there's a convenient sign in with Google or sign in with Facebook. So you might go, well, what's Google get out of that? What's Facebook get out of that? Why do they? Well, they get all the data.
Right.
And so Apple was like, look, that's really convenient, and we'd like to have other apps offer that, but Apple is all about privacy right now, right? And that's the big differentiator that they're going after Google. And so they have a new sign-in with Apple, where Apple's like, look, we got no dog in this hunt. We don't care. We're not tracking you. We want to give you a convenient way to sign on without giving up all your data. And so that's what they rolled out.
Why doesn't Apple or Google build a Facebook alternative? I mean, I know Google built like.
Google kind of
what did
did.
they do? What did they call it?
Google Plus.
Google. But I mean, so
Um,
many people would like to get rid of Facebook, but
But why? Why do they want to get rid of Facebook?
because the perception, I guess, is that they're not, oh, the whole process. You want to go on?
No,
I'm
it's
just
fine.
like curious about this stuff. I mean, the perception is that they don't protect any information, they sell all your data. I don't have communications that anybody would be interested in, but.
You'd be surprised.
I mean,
So
I know it's worthwhile for businesses, because they're always trying to sell me stuff, and I search for it.
Mhm.
Although usually after I buy it. But
So
anyway, so if I wanted to, but if I wanted to quit Facebook, I wouldn't really have necessarily a comprehensive place like that with all my pictures and stuff.
right. So
Uploaded.
here's the important thing to remember. That all the for photo storage, all of the connections, all the databases, all of that is very expensive for Facebook, right? It costs Facebook. I'm going to throw a number out there. This is not substantiated in any way, shape, or form. It costs Facebook $5 a month for you to use Facebook.
Right.
They have to pay for the servers, the electricity, the networking, the internet connections, the developers, all of that stuff, right?
Mhm.
Okay. Do you want to pay $5 a month for Facebook?
I think if it was explained to me properly, I would. But
Do
like
you
I pay
think-
for like Hulu not to have commercials,
Sure.
so.
Do you think the regular how many people do you think, what percentage of Facebook
Right, I
users
get
do you
that
think
part.
would pay $5?
Yeah, probably no,
Like
So-
1 or 2% if I did
a small.
Yes.
A very
Yep.
small
Right.
percentage, yeah.
Although I
And
think I heard someone say, and this was already a couple of years ago, so it's could be off now, $12 a year.
is what,
That costs,
yeah.
what I would have to pay, which I would certainly pay, if it was explained to me that it was for. And I mean, for me, when I think of privacy, I always think about it in terms of law enforcement,
Mhm.
because that's the only place where I've really encountered it, except for the ads that pop up, like stuff like that. And I know that if someone took a deep dive, they would find out all kinds of stuff about me, but I'm really not all that interesting, except for my buying power, which is a big deal.
Right.
But I mean, it's not like I'm plotting an overthrow of something or,
So there's a lot of trust that you have to put in Facebook, that Facebook has all that data about you. And their big thing is that, yeah, we don't let advertisers know that it's you. We can let advertisers filter down, right? And, I want the Syracuse area and I want female and I want this stuff, but they never see that it is you.
Right.
And they never see that it's you, even when they click on the ad and you end up going to their website, they don't get to see, I'm clicking in, I get all your Facebook. None of that gets passed off. The reason why Google or Apple or any of these don't want to create a social network is, Google tried, but Apple in particular, Apple goes, well, no one wants to pay $12 a year for a social network.
Mm-hmm.
And there is a critical mass that it takes for a social network to work, right? So if I create a new social network,
Right.
I
Nobody's
spend
on it.
time and I put all my photos out there. I'm like, yay. And I'm like, you guys should all join my social network.
Right.
And you're like, why? Right? Like no one else is on it. I don't care about you enough. Right? Like, and so you have that problem with any app that you create. Is that if it is a social network based app, you need to get a critical mass of people using it in order for everyone to continue to use it,
Right.
which is really hard to topple Facebook there. But the other side of that is okay, well, if you want the privacy, then pay the $12 a year. I don't want to pay $12 a year. I'll just keep using Facebook.
But I think Facebook has gotten enough bad publicity that people, I don't know what that critical mass is. I have no conception of how many people would have to sign up to make it worth their while. But since you're focusing as an Apple on privacy, I think there are enough people at this point who are becoming more concerned about privacy that might consider that. Like I would certainly pay $12 a year for that. But I
Sure.
don't know if I have no idea if that's a widespread feeling or if it's just because I read too much news. I don't
So
know, that could just be me. I don't know. I mean, for me, I've just had so many different lifetimes, I guess, that it's hard for me to keep track of people, like people in college, I would not have been able to hook up with had it not been for Facebook
Mm-hmm.
or other things, which is why people do it. But, you know, a lot of people do feel, I think people are more comfortable with, or less comfortable with their really kind of slipshod, it seems like, because I don't know anything about it, but kind of slipshod handling of private data. That's aside from their actual selling of data.
So
Well, like,
Facebook,
started with like just like college students,
Yeah.
and they already
Mhm.
had this like network, and there already was a low threshold for like privacy, because college students are just like, hey, you're my
Yeah.
friend.
Mhm.
So I think that they already had this sort of like base that it would be very.
Yeah, but
difficult
now,
for
I mean,
everybody,
now they're influencing elections, you know, now it's really,
right?
whole
And they didn't
different-
intend for that.
Yeah,
They were
but
just
they-
like, oh, we're just gonna hook these.
and I don't
houses
think they care.
What would be the difference at some point, right? If people left Facebook for a different platform and that platform grew to be as large as Facebook, the same thing
Mhm.
is gonna happen.
Yeah,
It's just gonna be a different platform.
presumably,
People
unless
were
you
like, oh,
did have actual privacy where they weren't selling that data.
Except there's always gonna be a market for data.
Of course.
So
So that's
There's-
why I'm saying if Apple's focused on privacy, if that's their new thing. it
Right,
would make
so-
more sense for them to do it than say a Google, who nobody thinks is private at all.
so the only company that has more revenue in ads than Facebook is Google.
Right,
Google's revenue from ads is around 100 billion,
right, 'cause they sell your data.
which is why when I say what kind of company is Google, and everyone, oh, it's a tech company.
Yeah, they're all ad companies, just like all the media.
Well, not all of them, but like Apple is not an ad company. Apple is focused on software and hardware.
Right.
So when you look at it, Google, I just off some basic numbers, they are 1.52 billion active users and they have 16 billion in revenue.
Right.
So if you know, they're operating, I mean, you can roughly do that math, right? 16 billion divided by 1.52 billion users. How much do they make off each user? And then look at the cost of that. Say, okay, if they're making 50%, right? The other costs go to that. You're now getting roughly how much it costs Facebook to
Right.
store your photos and
Right.
have all the servers and developers and all that stuff. It's expensive.
Yeah.
And do you really want to look at those numbers and say, okay, not only are we going to charge users for privacy, but now we have to get that critical mass. And if we don't get that critical mass, we lose the investment. So that's why Facebook doesn't have a major competitor.
Right.
And that's why
Well,
Google
they buy
didn't.
up any other competitor. So like WhatsApp or
Um,
Instagram, they own too.
Sort of like
Did you own
competing
Instagram?
but complementary things, like they have the messenger thing, right? And like.
Yeah, they're a
all the stuff
monopoly
about
though. I
messengers,
mean,
they have
Well, they're not a
other
monopoly.
thing, And they just link Instagram, they don't try to kill Instagram.
yeah, but that's just because you think, oh, I'll go to Instagram, but Instagram is owned by Facebook. So it's still the same people doing the same things with your data. Same with WhatsApp. Because my cousins in Germany, they only use WhatsApp, which drives me crazy. In Europe, WhatsApp is
Mhm.
huge. Everybody uses WhatsApp.
Yeah.
But I don't routinely use it here for any particular reason. So
Good.
I know people do. I just don't need to have 50 billion social media. But they're like, well, it's much more private. It's like, no, it's owned by Facebook. I mean,
Well,
what
it-
you're trying to avoid, but under a different guise.
They do use end-to-end encryption on WhatsApp if enabled. So it is a little bit more secure. Facebook still gets their metadata, but it is more secure than using something like Messenger. But Facebook is not a monopoly, right? There are other social networks that I can go out there and use. Just because those social networks don't have critical mass doesn't mean that Facebook is a monopoly. I don't have to use Instagram. I can go to MySpace and use MySpace if I wanted to, right?
Does that still work?
Yeah.
MySpace is still around.
Still works.
I haven't been,
Really?
on my- I don't think I really ever went there.
So yeah, all right, back to coding.
Okay.
Okay, so I just closed Glitch by accident. Okay, so we have one more thing that I want to cover. Reminder for tomorrow, start thinking about questions from the past 3 months. projects or homework that you haven't completed, stuff like that, we're just going to do like a very extended office hour section. That also goes for any topics. Like if you have any topics that you would like me to talk about, feel free to send them to me now and I can prep for them a little bit. But if you're like, oh, I would be interested in this thing that we glossed over, or, you know, I keep on hearing people talk about this, I am happy to do a dive on that. And just a reminder on why we're doing that, we've kind of reached our limit of Node. So we can't do too much more with Node until we have the database piece of it. So once you get that from Gus in the next 2 weeks, we'll come back and dive into different frameworks, Sales.js and Meteor and a couple ones like that. We'll dive into what they call CRUD operations, create, read, update, and delete. We will do a deeper dive on middleware and authentication. We'll be getting into all of that. But tomorrow is your chance to kind of regroup, refresh, figure out where you guys are at, where you got stuck. And it could be as simple as, can you go over some syntax, like I keep on getting lost in my curly braces, or it could be whatever. So that's for tomorrow. For today, what we are going to do is we are going to wrap up with something called EJS. So when we look at our code here, we have this templating, right? And what we're doing is we're defining out our HTML, and then we're using those $ curly braces to inject in our variable. But what if we had like thousands of rows of data, right? That could come back to the front end, and the front end could be like, man, that is a lot to render out and put into my HTML. I would rather the server go out, build all of that HTML for us, and then you can just give me the HTML and I'll show it. I don't want to have to build it, right? And that's a very common thing. If we go to Amazon.com, right? This page is not built out on the front end, right? It doesn't go, oh, let me load in the basic HTML and then let me put in the deal of the day. Let me go do an API call for the deal of the day. And oh, let me go see what the second box content is. Let me go do an API call for that. And oh, let me go get your recent orders. Let me go in and get that, right? And oh, I also need your how long you've been a customer. That's another API call, right? You would probably have hundreds, if not thousands, of API calls to build this page. That would make the browser blow up. And then as those API calls would come in, you'd have to constantly be updating your HTML, right? So what Amazon does instead is it goes, oh, you want Amazon.com. Okay, let me go do that. Let me go get all that data on the server side, assemble that all together using a templating engine, and then return you one HTML file so you don't have to make, you know, a bunch of different API calls. So that's what we're going to do. We're going to do a little bit of a shift. We're not going to do this right in our messaging app. And the reason for that is the messaging app, you're always going to need some API calls that happen on the front end, right? You're always going to need, when a new message gets sent by someone else, you need to make an API call or have that socket information coming in. And when that socket information comes in, you have to update the front end. So a templating engine isn't really a messaging chat app isn't a great use for a templating engine. However, there are plenty of uses for it. So we're going to use our same project to do the templating engine. We're just not going to do it with the message focus. Yes.
This may be not where we're going, but so with Amazon, so it changes every day. Like how far in advance do they do it in advance? Like, oh, you know, this is what we want on this day, and then it's going to change to this on this day, and then it's going to change to this on this day.
Are you talking from a content perspective or from a coding perspective?
From, I guess, coding perspective.
Okay, so the you know, obviously thousands of people work at Amazon, and so the content team's completely separate, right? So they have their own CMS, content management system, for loading in these ads, and they have that all scheduled, and the developers make it for them and integrate it, and they don't touch any code. They just upload their images and it's done. From the coding perspective, there is a rapid deployment cycle where basically Amazon deploys, and there are like TED Talks on this, or maybe they're not TED, but YouTube talks on Amazon does between anywhere between 60 and 3,000 deploys a day. And they are deploying so much because it is all segmented during their rollout, right? So when they deploy a feature and only 1% of Amazon gets it. So you might go on Amazon, you're not going to see that. Facebook does this by region. So if you're, and I've noticed this, if I'm in San Francisco, I go to Facebook, I'm like, oh, that's different. That's not how, just like a little gradient change, or there's a drop shadow on that, or whatever it may be. But when I go back home and I refresh Facebook, I'm like, wait, where did my drop shadow go? And 4 weeks later, I get my drop shadow back and it stays. And the reason for that is they were testing that out in San Francisco. But when you talk about 1% of all Amazon users or Facebook users, you're talking about tens or hundreds of thousands of people. And so that's how Amazon is constantly deploying their code. But while they are deploying, it may be as simple as like, oh, change browsing history to just history. And so only a couple people will get that, and it will just be deployed constantly. And as more and more people see that, it will eventually get to 100% of the Amazon user base. Cool. Obviously, that is not a easy problem to solve. But it's called CI and CD, continuous integration and continuous deployment. And they are set up in such a way that, obviously, I mean, how many millions of lines of code must Amazon have, right? So when they do a deploy, they don't have to deploy all million lines of code. They can just do a small section of it and just build little pieces and then roll that out, which is a major infrastructure challenge for sure. Okay, so we are going to get started with EJS. So we are going to go to our console, and we are going to npm install --save EJS. And I believe EJS is actually built into Express, so we don't need to do this step. But it's still a good idea to run this. So it's saved into our package.json. It's saved into our dependencies. So when someone else opens up this project and goes, what are we using? What technologies here? They can go to our package.json and see that we added okay, no, you're just gonna reconnecting. Or because I refreshed it. Collaborative coding hates me.
Totally collaborative troubleshooting at this point.
So this is what I do when things don't work. I signed up for a gym membership today, and I went to.
I was just about to buy something.
I bought I went to like buy the personal training sessions, and it just went, oops, something went wrong. And I was like, oh, okay. And so normal thing to do would like email them and be like, oh, hey, I can't buy this. No, what do? I go in the JavaScript console and I see blah, blah, blah is undefined and I screenshot that. And then I go in the network tab and I hit the send button and it 500s and I go click on that error and I go, oh, did you look at that? And I send that information along. So when you are a developer, you learn to really appreciate other developers using your software because, you know, when you get a bug and it doesn't work, you're like, well, what do you mean it doesn't work? You go do it yourself and it works fine for you. And you're like, whoa, it works fine for me. And then you have to get more information. But when you're working with other developers, the other developers like, look, I want to know that at 500, I want to know what the response was on the 500. I want to see your JavaScript console, and then I'll go fix it.
I'm gonna email the IT guy at work and try to get it right. Because my computer work is just a mess.
Can you guys see my code?
I can see it, but it says, we're having trouble connecting private traffic.
I think it might be a bad omen for color your website.
Always like that, it has to be.
It's so low.
All right, we're gonna, you guys wanted more project practice. We're gonna do it locally. Visual Studio Code. Please contain your enthusiasm.
This is not chat app, right? Are we using the chat app?
No, we're gonna do a new project. New project. Here we go. We're gonna blow this up. I'm gonna CD to my desktop. What am I gonna do for a new project? I'm gonna knit. First, I'm gonna make a new directory called EJS, and I'm gonna CD into my EJS, and then I'm going to npm init. It's fancy. It's a lot easier to read. Yeah. So styling your terminal is like kind of like a programmer badge of honor. Yeah. So yeah. Enter, 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 enter. Okay, now what?
Okay, what was it? I'm sorry.
I called it EJS because that's the templating engine we're going to use. And we're gonna need a server, and we're going to install anyone? Express. npm install -- save express. And we're also going to need EJS, so we're going to install that as well. Maybe we don't need to install EJS. Yeah, we don't need to install it because it's built into Express.
Oh.
Okay. What else do we need?
What are we doing?
We are creating a server that is going to serve a file with some data in it. We probably need a file to write some code in. What? We init it up here. We init it up here. Okay, so we're going to open that up in Visual Studio Code. And we're going to create our new file called index.js. And we're gonna blow that up. And how do we get started with Express? And once we have Express, what do we need? And before before we do our endpoints, we don't want to forget to listen on 8080 on any IP address, which we don't really need because we're on local. And then we are going to console.log server is running. And then we are going to fire up our server, nodemon index, and we're going to go to Chrome and check out 8080. And it does not want to do that. Nodemon index.js. I'm missing something. So we don't have our servers running here. No, because it should still start the server even if we don't have any endpoints. You do? Well, I must have something running on 8080, so I'm going to use 8081. Okay. So now we're going to get into the new stuff. So we're going to tell Express, hey, if we are going to send something back using a new thing called render, we are going to use a new, they call it a view engine. So we're going to say app.set, and it's going to take two parameters. And Visual Studio Code is going to help us out here. It goes, what do you want to set? We want to set our view engine. And what do we want to set it to? We want to set it to EJS. And then what we're going to do is we're going to say app.get. And what do we get? We get our rec-res. And let's just res.send hello world. And we're going to take a quick peek here and we get our hello world. So we know our server is running as it should be. Okay, so let's create a new file. And our new file is going to be called index. And instead of .html, we're going to do .ejs. And so we're going to get some new syntax in EJS. But to get started, let's do a h1 with a hello world. And now we want our Express server to send back this file, right? So how did we send files before? How did we send index.html before? Res.send file, exactly. So we're gonna, instead of res.send file, we are now going to res.render. And what render is going to do is it's going to, instead of just sending the HTML back the way we have it, we are going to send back the EJS file, but we're going to process it first. In this case, there's nothing to process. It's just HTML, so it's going to send it back. But what Express is going to do is process this on the server side before it actually sends back the value of the EJS file. So we are going to say send back our journey plus index.ejs. And we'll save. Our server rebooted for us because we're at nodemon. We're going to refresh. And we cannot find module EJS. Okay. So we are going to try this again. npm install EJS. Choosing to install package with name EJS under a package. Oh. Okay, so what this is saying is that it won't install EJS for me because in my package.json, I called the project EJS. So it's cranky and it's going, no, you can't have two things called EJS. You can't have the project called EJS and the package you're trying to call, to install called EJS. So I'm going to call it EJS2 or EJS project would be a better name. Adding a number to something is rarely the right solution when naming variables. Final, two, final, I mean it. So now let's try and install EJS again. EJS installed. Let's fire up our server again. And now let's try and refresh. Okay. So we got nothing. Let's go to our index.ejs and make sure I saved that and refresh it. And there's our hello world. Okay, so nothing's really different here, but let's start to have a little fun. So let's pass some data into our EJS template. So instead of just passing it the name of the file that we want to render, I'm going to pass it some information. And in that information, I'm going to pass it an object called cars. And those cars are going to be Toyota and Honda and Ford and GMC. I don't even know if GMC is still around, doesn't matter. Okay, so when we save this, is anything going to change? Right, we go in here, we refresh, it's exactly the same. But what we can do is play around in our index.ejs and put out some information. So I'm going to do a UL item, a UL tag. And in our UL, I'm going to use some new syntax. I'm going to do a arrow and a %sign. And in that, I am going to say cars.forEach. And we are going to have a function that gets a car. And that function is going to do something. And what that's going to do is, this is a little weird. This is similar to PHP syntax, if you guys have ever seen that. We're going to close out our tag. And then down here, we're going to reopen our tag.
What is the symbol before cars? It's a
%sign, an arrow and a %sign. Okay, so this might look a little weird, but we're going to save this and we're going to refresh and we get nothing. So what's interesting here is this for loop is actually running, but we didn't tell it to do anything yet. So what we're going to do is we're going to drop down in here and we're going to say, hey, make a new LI tag, an opening and a closing. And we're going to save that and refresh. And we got 4 bullet points. Why do we get 4 bullet points? Well, we have our 4 cars that are coming in. So how do we get those cars to show up? Well, in our LI, if we just write car, we're going to get car 4 times. So what we're telling it with these tags is, hey, we're in EJS land now. So switch out of basic HTML, figure out whatever the HTML is in that EJS, and then spit it out onto the page. So if we save that and refresh, we don't get our cars. Because instead of using just our regular EJS tag, we're going to say equal. And what that equal is going to do is it's going to say spit out the value. So when we refresh, we get our cars. So I'm going to do one more example, and then you guys can figure out what your homework is. I mean, your homework is to implement sockets.
go home and implement.
Oh. So what I'm also going to do while you guys are looking at that, I'm going to do a new thing here. And instead of cars, I'm going to say models. And in the models, I'm going to do another array. Go away. It's not going to. And I'm going to do a manufacturer. Manu is Toyota. And the model is going to be a Camry. And we are in JavaScript here, so we need our quotes. And then we will do another object here, also called menu, and it's going to be Honda, and the model will be CRV. Okay, so we're passing in an array still, but now we're passing in objects in that array. So if we go back to our index.ejs, we're going to leave this for each, but now we are going to do a for each over models. And our UL is going to, I actually don't know how to do an indented UL. Is it just another LI? UL. Okay, well, let's try this. Never done this. We're gonna do UL, and it's gonna have an, oh, that's how you do it. Never mind. We're gonna put this back out here, and we're gonna put this out here, and we are, instead of car, we're gonna call this model, and we're going to say model.menu. And then in our LI, we are going to do another UL, and that UL will have an LI of the model.model. And we're going to close our tag and watch everything blow up. Oh, that's what I wanted it to do.
Oh, very nice.
Same concept here, just to show that you can dive into your objects and access different properties in your template.
So what's making it indent?
It's because there's a UL in the LI. There's a UL in this LI. Yeah. So it's like, wait, I know what I want it to do. I don't know how to do it in the code. That is valid HTML though. Okay, so your homework assignment before you leave is to get the basic car code working. And then your extended homework assignment is to play around with sockets. I'm going to leave both of these up on the screen. I'm going to attempt to leave both of these up on the screen.
There's a split. There's a split
Yeah.
up at the top, right?
Could you put it in Slack?
Sure can.
Easier to see. Just gonna do live stuff.
And with that, I'm going to end the live stream unless anyone has questions. Does everyone understand why we would use templating, or what the difference is between what we did in the chat app, the messages app, versus what we're doing now? The big thing is that we're moving, instead of generating that HTML on the front end and getting the raw JSON, dealing with the JSON, building out the HTML and making it all happen on the front end. Instead, we're taking the data that was already on the back end, rendering out all the HTML, doing all the strings and injecting our data into that, and then returning that finalized HTML to the front end. And so this is an important note. If we go to view page source here, all we see is the ULLIs, right? If we look at this code in our browser, That's all there is to it. We don't see the for each. We don't see anything that's happening on the server, because all the server is doing is returning the finalized HTML to the client. When we did it on the chat app, which isn't being cooperative, what we would see is all the JavaScript, right? And we would see the raw HTML template, and we would see the JavaScript executing and putting that into our div all on the front end. So if you wanted to abstract that away from the end user, you could do it in a templating language instead. Okay. We will revisit templating when we get back to Sales.js, and a little bit in Meteor. And then you will also see what the newer version of HTML templating is with React. And I use the word version very loosely. So focus on getting the EJS working. If you can get the EJS working, play around with sockets. No big deal if you don't get it working for the homework, but it's a good thing to practice, spinning up a new server, installing the dependencies, and then seeing the benefits of running a socket.